FT8 Fire System, Cause and Effect Drawing. Fire protection of the turbine package is critical for both equipment protection, and more importantly, personnel safety. The FT8 Fire System is supplied by Associated Fire Protection, AFP, who provide several types of extinguishing systems depending on the application. The most common configuration uses carbon dioxide bottles, which discharge carbon dioxide into the enclosure to displace oxygen and smother a fire. Supporting this system is a significant amount of dedicated hardware that must be continuously monitored and controlled. This fire system operates independently of the turbine main control system. For each FT8 installation, AFP typically produces a cause and effect drawing. This document defines the intended operation of the fire system control logic, known as OnGuard. The cause and effect drawing is a critical reference during commissioning, and later becomes an essential tool for maintenance and troubleshooting of the FT8 fire protection system. Let's take a closer look at what makes this drawing so useful, and so important. The cause and effect drawing is laid out as a matrix, with the cause inputs listed down the left side, and the corresponding effects shown across the top. We'll start by reviewing the cause inputs, and then move on to how each of those causes drive specific system actions. This is an example of the cause inputs you would typically see on a mobile pack, or a swift pack unit. On a twin pack, the same structure exists, but with separate inputs for gas turbine A, and gas turbine B. The inputs are grouped by 4 physical locations: hydraulic start, generator, gas turbine A, and the control room. Hydraulic start protection dates back to when the hydraulic starter had its own enclosure, and was protected by a thermal detector. This configuration is no longer used on modern installations. Generator fire protection is available as an option when purchasing the equipment, but it is rarely selected. Generators are generally considered a low fire risk, which is why this protection is often omitted. The gas turbine A inputs are standard on all FT8 units. On a twin pack, you will also see a corresponding set of inputs for gas turbine B. Finally, the control room section may include some or all of the inputs shown, depending on the specific project design. Let's walk through a simple fire event example. The FT8 uses thermal detectors for fire detection. It does not use ultraviolet or infrared flame detection. If a thermal detector, for example, TS204, detects a fire, the detector's thermal switch contact closes. That contact closure is detected by the OnGuard fire controller, which then processes the signal as a confirmed fire input. Next, we'll look at the effects portion of the cause and effect matrix. Starting at the thermal detector TS204, we move horizontally across the matrix to the first cell marked with an X. That X indicates an effect resulting from the fire detected by TS204. Moving vertically up the matrix, we first see a general alarm, XA203, enunciated in the control room. At the gas turbine location, several additional actions occur. The enclosure dampers shut closed, trapping the carbon dioxide inside the enclosure to smother the fire. Both fire bottle discharge solenoids, SOV201 and SOV202, are energized, initiating the carbon dioxide discharge. At the same time, the fire strobes and fire horn are activated, and the fuel fire valve FV1003 is de-energized, causing the valve to close, and remove the fuel source. Every input on the cause side of the matrix has one or more corresponding actions on the effects side. During commissioning, and the annual fire system audit, each of these inputs and outputs must be verified to ensure the system operates exactly as intended. Solar turbines do not provide this type of cause and effect drawing, but it is a document that you can, and should, develop for your own facility.